he's also getting a hierarchy of oracles in which you have a first oracle for the halting problem. Then you have an oracle for computers that have an oracle for the halting problem. That's called the jump of the halting problem. Then you have computers which have an oracle for programs written for computers that have an oracle for the jump of the halting problem. That's called the double jump of the halting problem. And you get this whole hierarchy of more and more powerful oracles, and this idea of computers that are more and more powerful than real computers could ever be. And it's a very big structure. So that's the 1939 paper.
But this is much less known.
This is much less known.
Okay. So this is yeah. Now I remember where I stopped. So this is when we think about this new math that is being applied, and we really think that our idea of the math here is not just for quantifying and modeling and prediction, but also for understanding why a certain phenomenon actually I wouldn't say behaves, is set up in a certain way, relating certain, let's call them variables, or certain concepts in a certain fashion, thinking about mathematics as a kind of a language that really elicits this kind of connection as it happens in nature. We also think that metabiology is really working with the principles that rule, or that guide the biological process. We're not really thinking about the biological process itself. This is why it's metabiology, and it is. I came up with this sentence that making biology mathematical, but doing so at a meta level. And now with all this that has been going on lately, this week and weeks before, when we were in Sao Paulo, we are starting to notice that metabiology, surprisingly, but maybe not so surprisingly, can communicate with two different theories, because theories are methodologically at, let's say, a lower level than a meta-theory. So being metabiology at a meta level, it can sort of communicate with two different biological theories, namely what right now is neo-Darwinism and what is now coming as this new proposal by Massimo Sandin that entertains different mechanisms for the processes of biological phenomena. This is just something that we would like to think together with you. What is metabiology after all? After all this talk, then this is new area of interdisciplinary and paradigm shifting, scientific research, methods, techniques from different areas, concepts from different areas. The basic analogy is DNA equals a programming language. The goal is slightly different from Darwinian and neo-Darwinian applications of mathematical applications of math to Darwin's or neo-Darwinian interpretations of biology, because here the goal is a proof. Here is to show that there is a life form that does evolve according to natural selection, filtering random mutations, but simultaneously, and this is very important, we want to explain biological creativity and where the new genes come from. So this is what we think that really makes us slightly different from the current, the most common neo-Darwinian research. What emergence of novelty requires a fundamentally new kind of mathematics that deals with creativity. This is why we are using what was called the post-Gödelian math. In this outline, we have this sort of set in different words. From the modern synthesis of neo-Darwinism, we get our basic analogy, we get the process by which we want to make the model work. From algorithmic information theory, we get our toolkit, And in metabiology, we get this new vocabulary, this new set of concepts. And the creativity is over there very central, much more than competition or adaptation, as in other interpretations or in other forms of expressing the modern synthesis or neo-Darwinism. And this is when we finally saw that we are drifting away from the neo-Darwinist interpretation more and more. First, initially, we were really stressing on creativity. This does have, if you really think on an interdisciplinary approach to biology, not only to metabiology, but to biology itself, it does have consequences to how the scientific community, and therefore part of the population of the world that pays attention to what scientists think, how are we going to think about ourselves? Right now, it is very common to take it as granted that we are competitive, that the fitter survive, and there is no really an alternative to this kind of view. The selfish gene seems to be accepted basically by everybody as if it were this sacred truth. We think that maybe metabiology can show us a different direction, which is always very difficult. I was the other day thinking that when the Renaissance came and humans were supposed to think about themselves in different terms than the terms imposed by the Middle Ages, it was actually very, very tough, in the sense that in the Middle Ages we were supposed to be creatures, in Europe I mean, creatures of this monotheistic theology. We were here to expiate our sins, and we were basically fallen creatures. So when Renaissance came, sort of trying to remove, how do you say, to bring human beings and the human existence out from this level of sin expiation, it was very difficult to convince people that humans were actually different from what was the view of humans in the Middle Ages. And I sort of see similarities here too. We are sort of now bathed by this understanding that we are competitive creatures, that we are basically carrying selfish genes around, and thinking that maybe in the life process, creativity may be more important, seems as wild as probably humanism seemed when it was first proposed in the Middle Ages conceptual context. On the other level, we are starting to notice that metabiology is shifting away from neo-Darwinism, given the results of the mathematical model. When, as Professor Chaitin said, algorithmic mutations were really necessary to put the model to work, not point mutations, and we had this very interesting result comparing the evolutionary speeds that has already been discussed here. We start to think, how much does this corroborate the neo-Darwinian paradigm, given that we're using algorithmic mutations, and algorithmic mutations may be not as close to neo-Darwinian whole paradigm as they may think, because we do not really have these let's say, evidence for believing that there were only point mutations in nature. It has been a problem that there are the missing fossils of intermediate life forms that were supposed to be expected according to Darwinian theory of evolution, that was mainly based more on point mutations and not on high-level algorithmic mutations, although they are present in viruses. And how this can happen is something that is really a very interesting theory that now we are getting in touch with here through Professor Sandin. So anyway, let us think on conceptual terms again. You have probably taken a look at this while I was talking. So the conceptual framework leading to neo-Darwinism really comes before Darwin. There was, of course, the knowledge by Darwin of Malthus and Herbert Spencer. He actually cites them in his on the origin of species. And of course, other people besides Darwin did know that if evolution took place, this was sort of of common knowledge for people who were interested in biology at that time. And this was something very interesting that came up when we were preparing this talk, is that you can have this conceptual recipe if you take the random mutations, natural selection, competition, and adaptation to the environment that were already there before Darwin and that Darwin put together to the whole biological world instead of only thinking about it in social, economical, and political terms like Malthus and Herbert Spencer did. And then you add the Mendelian genetics and the concept of the gene, and then you add the mathematics and population genetics, then you do have what is basically the neo-Darwinian scenario today. Then from this, we start using this conceptual framework and we start developing it. We meaning the scientific community that works with neo-Darwinism. And there is a problem. There is a problem because according to this conceptual framework, it is very tough to explain why is there cooperation in nature. Where does it